Right when the scientists at NASA arranged and cultivated the James Webb Space Telescope, they believed that it would deal with how we could decipher the universe and help us with investigating the fogginess of space. However, to their disappointment, this super telescope planned to uncover what many had feared for the majority of years. Only minutes earlier, while looking at a dim opening, the James Webb Telescope identified a baffling space contraption. The getting of this accident course with fate could have shot the James Webb Telescope into incredible status. Anyway, it has sent the cosmology world into a free-for-all. What is the X7 transport? Why is it headed towards a dull opening? Could dim openings go about as limitless entrances to inconceivable achievements of computation and correspondence? One of the primary attributes of the universe is that it is an interminable region of space. For a seriously prolonged stretch of time, individuals have been captivated by and enthusiastic about the mysteries of the universe and long to open the secrets of the universe. This longing has driven us to envision planning marvels that are a reference point of our mechanical progress and reasonable achievements. One such marvel in space examination is the James Webb Space Telescope. It is the latest in a long line of space telescopes and observatories. The Hubble Space Telescope was one of the predecessors of the James Webb Telescope, shipped off in 1990. It is one of the most famous and convincing telescopes and helped us understand various things about the universe, including the expansion rate. Another critical telescope is the Spitzer Space Telescope, shipped off in 2003. It was useful for seeing cool objects like natural-colored, more modest individuals and focusing on the advancement of stars. In 2009, the Kepler Space Telescope was expected to outline a piece of the smooth way of the infinite system, also finding planets revolving around various stars. Another is the Fermi Gamma Ray Space Telescope, which focused on space idiosyncrasies like pulsars. James Webb stands apart from all the telescopes shipped off before it. The trip to the James Webb Telescope started with serious areas of strength for a vision to stretch the boundaries of space examination and broaden how we may decipher the universe. It was envisioned as the substitution to the famous Hubble Space Telescope, drawing inspiration from the triumphs and hardships of past space missions. The JWST was planned to overcome the limitations of its parentage and pave the way for historic disclosures in space science and cosmology. Following a surprisingly long time of cautious planning and improvement, it was ready to test the telescope to be shipped off in December 2021. The James Webb Telescope began its venture on an Ariane 5 rocket. Not like its progenitor, the telescope was advanced to see the universe in infrared light, allowing it to look through endless buildup fogs and capture pictures of heavenly objects that could have been hidden from various telescopes. One of its fundamental objectives was to study the development and advancement of galaxies, which would uncover understanding into the processes that led to the formation of our universe. By seeing distant objects in the early universe, the telescope will provide precious information into the world, stars, and planetary systems in our universe. The James Webb Telescope is also outfitted with state-of-the-art instruments to study exoplanets, which are planets that orbit stars outside our planetary system. By analyzing the environments of these distant worlds, scientists hope to reveal snippets of data about their composition, climate, and potential habitability, laying the foundation for future examination of alien worlds. One of the most groundbreaking capabilities of the JWST is its ability to capture images of distant objects in the early universe with its high-resolution instruments, including the near-infrared camera and the mid-infrared instrument. The telescope can detect faint signals from distant objects that are billions of light-years away, allowing cosmologists to investigate the universe's evolution from the earliest structures formed after the Big Bang to the remnants of ancient cosmic explosions. Clearly, the most exciting aspect of the James Webb advancement is its ability to observe the formation of stars and planetary systems. With its larger aperture, the telescope can collect more light than its predecessor, enabling it to see the faint emissions of energetic stars embedded within thick clouds of gas and dust. By focusing on these stellar nurseries, scientists can gain insight into the processes that govern star formation, from the collapse of molecular clouds to the formation of protostellar disks and the birth of planetary systems. These discoveries have expanded our understanding of the universe and paved the way for future revelations. The telescope is equipped with sensitivity and precision and is poised to unveil new insights into dark matter, the structure of galaxy formation, and the search for potentially habitable planets. NASA Chief Bill Nelson expressed that the James Webb Space Telescope is indeed a phenomenal achievement in engineering. With the telescope's ability to explore ancient galaxies and probe the universe's structure, we can now see the formation of galaxies that existed hundreds of millions of years after the Big Bang. Before this telescope, understanding these cosmic relics was considered an enormous achievement. Understanding these cosmic relics challenges how we decipher universe evolution, and there are already signs that the universe had more massive structures than we previously guessed. This discovery has disrupted all known models about large-scale structures, igniting numerous new scientific inquiries and prompting researchers to reassess the mechanisms driving cosmic evolution. Scientists have also been compelled to focus on dark matter in shaping the large-scale structure of the universe. Dark matter is considered the elusive force that subtly governs the complex development of galaxies. Astronomers and astrophysicists have been fascinated by this mysterious component for a long time. A true understanding of this force holds the key to unlocking the most significant secrets of the universe. The presence of dark matter makes it evident that it has a substantial impact on the formation and evolution of cosmic structures, leading us to examine the universe's composition more closely. The discovery of dark matter resulted from many years of careful observations and advanced technology. We understand that galaxies behave in ways that challenge our current understanding of gravitational dynamics. Their structures and movements suggest the presence of an invisible, undetected mass that balances the visible matter we can observe. The implications of dark matter's presence are vast and significant. Dark matter's gravitational effect acts as a colossal scaffold shaping the expansion and structure of the universe and guiding the formation and evolution of galaxies across the cosmos. Dark matter could hold the key to unlocking the secrets of the early stars and galaxies in the universe. It is believed that these early cosmic structures emerged from the gravitational seeds planted by dark matter density fluctuations. Intensive research and advanced particle accelerators have been employed to detect and study the elusive particles that might comprise dark matter. Complex simulations and theoretical models are also used to uncover insights into its properties and behavior. It is essential to note that the search for dark matter is not just an academic endeavor but has significant implications. The James Webb Telescope has provided dramatic insights into the mysterious universe of dark matter and massive dark holes. By studying the gravitational lensing effects caused by distant dark holes, the telescope has revealed that enormous dark holes existed in the early universe, much earlier than previously anticipated. With this knowledge, the scientific community is abuzz with questions about the origins of these massive entities and their role in the formation of galaxies. We also learn about the interactions that drive the formation and evolution of supermassive dark holes. This has opened new avenues for research into the nature of these colossal cosmic phenomena. Dark holes are these enigmatic entities with masses millions and billions of times that of our Sun. They exert such a strong gravitational pull that not even light can escape their grasp. While various theories suggest that these massive objects formed from the collapse of enormous gas clouds in the early universe, the James Webb Telescope is on a quest to uncover their true origins. Another theory proposes that dark holes formed from massive density fluctuations in the early universe, gradually accumulating mass through mergers to eventually become supermassive. According to observations made by the James Webb Telescope, this theory might hold some truth. Observations revealed the presence of extremely massive dark holes as early as 200 to 300 million years after the Big Bang. This represents a significant shift in how we understand dark hole formation and suggests that dark holes played a crucial role in the early development of galaxies. Additionally, the JWST has uncovered the interactions between supermassive dark holes and the galaxies that host them. When matter, such as stars and gas, approaches the gravitational reach of a supermassive dark hole, it undergoes a process known as accretion. This creates a swirling disk of hot gas and dust called an accretion disk. As matter falls into the dark hole, it releases vast amounts of energy as radiation and powerful jets of particles. These jets shape the surrounding environment and significantly influence the evolution of the universe. The impact of supermassive dark holes extends beyond their immediate vicinity and can affect the formation of stars and the evolution of galaxies on a cosmic scale. It is also important to note that the intense radiation and energetic outflows produced by these colossal entities can heat the gas within galaxies. When these gases are heated, star formation is suppressed, which can alter the overall structure of the galaxy. These outflows can also trigger star formation in other regions of the galaxy. This means there is a constant interplay between dark holes and stellar birth. The James Webb Telescope has transformed how we understand star formation and planetary system development by capturing images of stellar nurseries and protostellar disks. The telescope has provided invaluable insights into the processes that regulate the formation of stars and planets. At the core of how we understand the universe is the concept that our universe began with the Big Bang. This theory is the foundation that explains the diverse structure of our cosmic evolution. According to this theory, there was a singular point of immense density and energy where the fabric of space and time was created around 13.8 billion years ago. This singular event marked the beginning of our universe. In a fraction of a second, this primordial fireball expanded at an astonishing rate, leading to the grand symphony of cosmic evolution that continues to unfold today. Scientists have observed that as the universe cooled and expanded, the initial chaos gave way to the formation of the first subatomic particles, laying the groundwork for the building blocks of matter. These particles, governed by the fundamental forces of nature, coalesced into atomic nuclei and eventually into the first atoms. This intricate process, governed by quantum mechanics, led to the formation of stars and galaxies that would eventually give rise to human civilization. Scientists spent many years discovering and refining this model until the James Webb Telescope arrived, bringing new and significant discoveries. The revelation of dark holes and early galaxies has tested our understanding of cosmological theories. The JWST's observations challenge traditional narratives, revealing vast entities that seem to defy the established timeline. These early-stage cosmic giants suggest that galaxies may have formed much earlier than previously thought, raising critical questions about the timeline of cosmic evolution and the mechanisms driving galaxy formation. Traditional theories suggest that supermassive dark holes form through the gradual accumulation of matter over billions of years. However, the presence of massive dark holes soon after the Big Bang implies a faster and more complex process of formation. These revelations have caused a stir among scientists, prompting a reassessment of current cosmological models. Researchers are grappling with the implications of these findings, seeking to reconcile new insights with established theories. One potential explanation for these unexpected findings is the existence of alternative models of cosmic evolution. Some scientists propose that the universe experienced periods of rapid expansion known as cosmic inflation, which could have accelerated the formation of galaxies and dark holes.